Welcome to this episode of the CompTIA Tech Plus prepcast by baremetalcyber.com. Let's begin. Domain 4 of the Tech Plus certification, Software Development Concepts, introduces the core ideas behind how software is created, structured, and executed on various platforms. This section represents 13% of the exam and builds a bridge between IT operations and the development world. Candidates will explore the fundamentals of programming languages, data types, logical structures, and methods of organizing code. Even for non-programmers, understanding these ideas improves problem-solving, communication with developers, and the ability to work in cross-functional technical environments. Software development plays a critical role in nearly every IT setting, as developers write the code that powers applications, websites, and automation systems. For IT professionals, knowing the basics of code structure, logical flow, and the environments where code runs is essential to supporting and maintaining systems. Practices such as DevOps, scripting, and automation show how development integrates with system administration. A working knowledge of software development also enhances collaboration with different teams and improves technical decision-making. Programming languages are grouped into categories based on how they are written, how the code is executed, and the types of problems they are designed to solve. The major categories include interpreted, compiled, scripting, markup, and query languages. Each serves a different function, from building web applications to retrieving data from databases. Recognizing these categories helps IT professionals identify which languages fit specific use cases, ensures compatibility with target platforms, and aids in troubleshooting and deployment. Interpreted languages are executed line by a runtime environment, which means the code does not need to be compiled before running. Examples include Python, JavaScript, and Ruby, which are widely used for automation, web development, and quick prototyping. Because they can be modified and tested without compiling, interpreted languages make it easier to experiment and adjust. However, they generally run slower than compiled languages, because the translation to machine code happens during execution rather than beforehand. Compiled languages, on the other hand, are translated into machine code before the program runs, producing an executable file optimized for performance. Common examples include C, C++, Rust, and Go. These languages allow precise control over system resources and are often chosen for performance-critical applications such as operating systems or high-speed processing. The trade-off is that any change to the code requires recompilation, and developers need a compatible compiler for each target platform. Markup and scripting languages serve different but complementary roles. Markup languages, such as HTML and XML, describe the structure, format, and presentation of data rather than performing calculations or logic. Scripting languages, like Bash and PowerShell, automate tasks and extend the capabilities of other software environments. They can be used to manage files, launch applications, or generate content dynamically. In many projects, these two types of languages are used together, particularly in web development and system management. Query and database languages are specialized for retrieving and managing data in structured databases. Structured Query Language, or SQL, is the most widely used, enabling the creation, modification, and retrieval of data stored in relational systems. Queries can filter, sort, and report on information, making them critical for both application functionality and business analytics. Understanding the basics of these languages is valuable for anyone who manages or interacts with database-driven applications in an IT environment. Development environments provide the workspace and tools developers use to write, test, and debug code efficiently. Integrated development environments, or IDEs, such as Visual Studio Code, Eclipse, and PyCharm, combine features like syntax highlighting, code suggestions, built-in debuggers, and version control integration. These tools streamline the software creation process, reduce errors, and improve productivity by centralizing everything needed for development in one interface. Source code represents the human-readable instructions written in a programming language. which must be converted into machine executable form before it can run. This conversion is handled by either compilers for compiled languages or interpreters for interpreted ones. Along the way, syntax checking ensures that code follows the rules of the language, debugging tools help find and fix errors, and packaging tools prepare the code for deployment. Understanding this flow is essential for troubleshooting issues and preparing applications for release. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Programming logic fundamentals define how a program decides what to do and in what order. These logic structures control the flow of instructions, allowing a program to handle different situations dynamically. Conditional statements, such as if and else, execute different actions depending on whether certain conditions are true or false. Loops, like for and while, repeat operations until specific criteria are met. Comparisons allow data to be evaluated, enabling the software to make decisions and adapt responses based on user input or calculated results. Variables and constants are the named storage locations in code where data is kept during execution. Variables hold values that can change while the program runs, such as a running total or user input. Constants, in contrast, hold fixed values that remain the same, often used for settings that should not be altered. Using variables and constants correctly improves both readability and maintainability of code. Naming conventions and type declarations vary between languages, but follow clear standards to help other developers understand the purpose of each element. Arrays and other data structures store collections of related data in an organized way. An array holds a sequence of items, such as numbers or text values, under a single variable name with indexed positions. More advanced structures, like lists, stacks, and dictionaries, offer specialized ways to store and retrieve information. These are commonly used to manage user records, inventory lists, or transaction histories. Loops and conditional logic often interact with arrays to process each item efficiently and predictably. Functions are reusable blocks of code designed to perform specific tasks, often with inputs and outputs. Inputs, also called arguments, provide the data the function will work with, while outputs, or return values, provide the result. Functions help organize programs into smaller, more manageable parts, reducing repetition and making maintenance easier. This modular design also improves testing because each function can be verified independently before being integrated into the larger program. Objects and object-oriented programming concepts organize code around entities that combine data with behavior. An object contains attributes, which store information, and methods, which define actions the object can perform. Object-oriented programming supports key principles such as encapsulation, which hides internal details, inheritance, which allows new objects to build on existing ones, and polymorphism, which enables flexible interactions between related objects. These principles are used in languages like Java, C++, and Python to model real-world systems. Pseudocode and flowcharts are planning tools used before writing actual code. Pseudocode is a simplified, language-agnostic outline of how a program will operate, focusing on logic rather than syntax. Flowcharts use visual symbols to represent steps, decisions, and loops in a program's flow. Both methods help developers and IT professionals design algorithms clearly, collaborate more effectively, and identify problems before coding begins. These tools are also useful for exam questions that test understanding of logic structures. Commenting and documentation are essential practices for making code understandable to other people. Comments are short notes within the source code that explain its purpose or logic. Documentation, often maintained separately, provides detailed guidance on how to use a program, its requirements, and examples of operation. Clear commenting improves collaboration, makes troubleshooting easier, and ensures code remains usable long after it was written. In team environments, this is especially important for maintaining consistent quality. Version control systems, such as Git, track changes to source code over time. They allow teams to collaborate on projects, manage different versions of files, and resolve conflicts when multiple people work on the same code. Platforms like GitHub and GitLab provide cloud-based repositories where changes can be stored, reviewed, and merged. These systems are critical in modern development because they preserve project history and make it possible to roll back to earlier versions when necessary. On the exam, you may encounter scenarios where you must identify logic types, language categories, or the purpose of different code structures. Some questions might present small code snippets and ask you to recognize elements like variables, arrays, or object-oriented components. A clear understanding of these concepts also supports real-world troubleshooting and automation tasks, where recognizing logic flow can help pinpoint problems quickly. Several glossary terms are important to review, including variable, constant, function, loop, array, object, integrated development environment, pseudocode, source code, and compile. Studying these with practical examples can make them easier to remember. Using flashcards or quick quizzes that connect definitions with real applications will strengthen recall, especially under exam conditions. In real-world IT work, these development concepts appear in many ways. IT staff may write scripts to automate backups or deploy software, while developers create applications that require structured logic and testing. Support teams often work with error logs, configuration files, and runtime troubleshooting that rely on understanding basic programming structures. Mastery of these topics helps bridge the gap between IT operations and software development, improving communication and efficiency. In the next episode, we will take a closer look at programming language types, comparing compiled, interpreted, markup, and scripting languages in greater detail. You will learn how each category is applied, its strengths and limitations, and how these differences affect project planning and platform compatibility. Join us for Episode 41, Programming Language Types, Interpreted, Compiled, and more, as we continue building your foundation in software development for the Tech Plus certification. Thanks for listening. Please visit baremetalcyber.com for more cybersecurity information and education, including a new children's series. For more information on books and more, follow us at cyberauthor.me.